Thank you, Scott. Good morning, everybody. I know some of you in the room for sure. I've been around 29 years. I started when I was 10, so now you know how old I am. What I want to talk to you today about is electrical safety and design. And we have a thing called a bow tie up here, and I'll take you through a bow tie analysis. Is anybody aware of a bow tie analysis or done a bow tie analysis before? I see Rick. One person. Wow, cool. Dave and Doug, of course. It's just a way of identifying the risks that you're up against and how we mitigate those risks. So we'll walk through that in general. So just want to go through a quick poll. For those of you in the audience, where would you position yourself with respect to awareness of electrical safety? So it's all new to me, I have an understanding of the basics, I'm confident enough, or I'm competent enough. Do we have electricians in the room? We have one electrician, a couple electricians. Okay, I'm scared now. I want to scare the rest of them, okay? So you guys need to keep quiet or keep it down a little bit. I'd like to scare everybody in the room. How do we feel? How many of those are like me that actually shut off the power to the whole house if you're changing a switch? Yeah, I'm scared shitless of it. I really am. I don't see it, I don't feel it, I don't taste it. I don't know what it is. So if I'm going to do something electrically in my house, I'm going to shut off the whole power. I'm going to tell everybody that I'm shutting the power off in 5 minutes. You got that much time. I probably should be calling a contractor for that, yes. But do-it-yourself is do-it-yourself, isn't it? How about, which of the following would be what we call a top event? A top event means the shit happened, okay? How many of you would think either electrocution, fire, explosion, or all of the above could be a top event that could happen in electrical? All of the above, right? Which of the following would be an effective barrier? So think about design, think about having accredited installers and calling the electricians. Think about maintenance, periodically inspecting and testing those barriers or those pieces of equipment that we have to protect us. Or end-to-end assurance, to make sure that right from start to finish, we've got everything tested and in place to protect. Or all of the above. It's a little bit of a it's a little bit of a forced answer. How about, in your time in your role, have you ever been involved in one of the following incidents at a site or during a site that you've been maintaining or building where you've had either a fire or an electrocution? Anybody? I hear a yes. You've seen somebody get hurt. So the content I want to talk about is the challenges and the growing needs of the retail sites. And this is not Shell specific, this is retail in general. I want to walk you through sort of the Shell perspective, but it would be no different with Petro-Canada and Sunoco, Esso, and all of the others right across the globe. I'll walk you through an electrical bow tie just to get your thought processes working. And we'll talk about effective barriers. So, if I look at the challenges and the growing needs of retail sites, Shell has a thing called the integrated retail offering, meaning we're going to have things like hydrogen for vehicles. We're going to have e-charging at our stations. We're going to have the regular diesel and the regular gasolines. We're going to have offers all over the forecourt. And what I want to get from you guys is there will be what we call co-locators, but the third parties, the companies that we're partnering with to come in and offer our customers something different. So people that have electronically charged vehicles will have a place at our facilities to charge their vehicles. I just had a conversation about, e-charging gets to be about 5 minutes now. What do you do with that family for 5 minutes if you can't herd them into the store to get them to buy something? We don't want those kids walking around on the forecourt and walking into traffic. We've got alternative energies. I mentioned hydrogen, but we've got LNG, liquefied natural gas, and that's typically right now for big trucks and heavy moving vehicles. But that could possibly come down to the retail sites. So we're thinking long-term future here, what does a service station look like in 20 years or 40 years from now? If I look at the electrical site demand, it is growing, and we can remember that our sites are probably designed for a specific design. So we might have a C-store, we might have a car wash, we've got an HVAC unit, we've got a big canopy, a few dispensers, but that's what we designed for 10 years ago, 20 years ago. I've gotten to be so old that I've actually redesigned 2 sites that I actually built. So I've spanned that 20 years or 25 years, where a lifetime at a service station is probably about 20 to 25 years. And we designed it electrically for that. So now when you bring in an electronic charging company, and you're moving from what we call low voltage to medium voltage, you're going to need different switchgear, you're going to need different transformers, you're going to need to redesign the whole electrical system. Electrical safety. Hazards in electrical appliances and electrical infrastructure. Again, back to the top events, there's electrocutions, fires, explosions, overloads due to shorts and whatnot. But threats from poor workmanship and inappropriate design is really where we're talking about. And what I meant to say is we're actually right back to the grid on the street. So when we go to Toronto Hydro and we're designing a station in Toronto, we would ask them for a certain amount of electricity that we need from the transformer at the street corner. But now that was at low voltage, what we would call lower voltage. Now we're moving up to medium voltage, where we actually have to bring in more switchgear. Shell has put this on red alert, basically. So what we've done is we put an interim measure in to stop any future projects from being awarded, or the capital awarded to that project, until we have a proper redesign of the electrical. Because we just cannot say to a third-party company, you're the e-charging company, we'll just put up a wall, you guys build your stuff over there, and we'll just let you connect to our service station electrical panel. That's not on. So we've put some interim measures in. So it's really these heightened threats from the increased activity and that expanding scope, whatever that expanding scope might be. And the reason I wanted to talk to you guys in this forum was we need to be cognizant of that. We need to put ourselves into that spot to say, if I'm going to be servicing, let's say, a site where there's a new future fuel, let's call it, we need to understand what's behind that. Even if our contractors are not going to be actually the ones that are either commissioning it or installing that, we still need to understand what the ramifications are of that. We talked about LOTO. LOTO is one of the barriers, but we need to go right back to design. And the false outlook of all's good, and this is why I want to scare you, all is not good. If you're going into a site where you're looking at something that is expanding, you're going to want to understand, okay, where is the power coming from? Where is that distribution coming from? How are we going to let them tie into our distribution? So if you looked at a typical site where you had let's say a 900 or 1,000 square foot store, 4 islands, most of the electricity is from the chillers. So the RDC is the refrigeration deck coolers. This is a UK version. A lot of the food prep, and you see the interior and exterior lighting is quite small, but it's really about the chillers. Now we're going to be adding to that. So you can imagine if we started adding chillers and coolers and HVAC units to bring in, let's say, Tim Hortons into our stations, that's one thing, but now if we're bringing in e-charging or hydrogen for vehicles or other future fuels, we need to redesign the whole thing. And it's down to us as engineers and technicians, and society really puts great faith in that profession, right? That we want to go back to and trust the engineers and technicians to regulate themselves, but also we're ultimately accountable for the work undertaken at our sites, and people are the most effective barrier. So training and accreditation you'll hear a lot more of in our industry. So if you think about new projects, so we're building a brand new station at Spruce and Goose in a nice newly evolved neighborhood where we've got a whole bunch of houses going to be growing and whatnot. Certainly the barriers that we want to see in place are the design. We can go to the municipality. Typically we will have our electrical engineers and their electrical engineers working together to redesign or to design. And you're starting to think about the electrical schematics and proper earthing and bonding arrangements and all of that good stuff. The electrical equipment spec is the switchgear and the distribution panels, but we also want to think about what's the future. And that's why, for us anyway, we're looking at that whole integrated retail offer. So it's no longer just a store and a few pumps. We need to think about all those future fuels and future technologies that are coming. Extensions and modifications, and this is where most of the people in this room sort of play in this space. It's all about this modifications and whatnot. I had something from BGIS this week, and I have to give a shout out to Erin Yarosh. She's BGIS's HSSE advisor. She lives in Calgary. But 47% of occupational electrical related fatalities, 47% in the last 6 years have been through repair or maintenance work. And the reason for that is really about the leading causes are improper installations or procedures, lack of a hazard assessment, and really remembering that you need to respect the power. Like me, shut it off. Get your licensed electricians in there. We have had in the industry and Shell just last year in Pakistan, we actually had a technician, so a trained fuel technician. He was into a site in Pakistan to replace a meter in a suction pump and was electrocuted and died because of that. Why? Not to get into the whole philosophy of it, but the electrical system was up to the retailer or the dealer to manage, and this facility management company that was doing the pump repair work had nothing to do with the electrical coming underneath and up to the pump island. So he was doing his own thing, but really didn't understand that risk of this improper installation and was actually electrocuted from the feed coming up from the store to the pump island. So we don't ever want that happening again. So it's about load analysis, it's about circuit design, and avoiding large single phase and line loads, and the assurance on the electrical equipment, and testing grounds, testing what we call critical equipment inspections. So maintenance will only remain, we will only remain approved, certified if it's maintained accordingly, and ongoing inspection. So it's 100% of that fuel systems are tested annually. I'm sure we've all seen some of these sort of installations as we go from site to site. It's not like the schematic that we had 20 years ago. Somebody's been altering it, and it's been altered along the way, likely without taking proper permits. So electrical bow tie, and we've kind of stopped and thought, let's do an electrical awareness training for all of our staff and all of our contractors right across the world. And that's why I got this idea to bring it to you guys. If we think about the middle of the bow tie, the middle of the bow tie is what we call a top event. That's the thing that we do not want to happen. So if you think of working at heights, it would be that time when that person falls. That would be a top event. The left side of the bow tie is identifying the hazards and then putting proper barriers in place. So we'll start with the left side of the bow tie. If we think about top events, electrical burns, you can see on where somebody has actually touched the two contacts and gotten burns on their hands. Electrical shock. So what happens? So remember, most of the receptacles in the room here are 15 amps, maybe 20 amps, 15 amps, let's use. This is at 0.5 of a milliamp. Okay, so we're thinking about thousandths of an amp. At 0.5 milliamp, did you feel it? At 1 milliamp, yes, I did. At 6 milliamps, it's painful, and some women cannot let go, meaning they're holding on to it. At 10 milliamps, very painful, and some men might not be able to let go. At 10.5, all the women are stuck on now. And I'm not sure why they put men and women in here, but I would think probably just the way we're built, and they would be screaming at that point in time. At 16 milliamps, the men also are screaming. So between 16 milliamps and 30 milliamps, the muscles contract and your breathing becomes difficult. So now it's actually affecting your chest. But you won't die just yet. Once we get to 50 milliamps, it all depends on the time that you're holding on to it, the type of person you are, the type of structure you have, what you're standing on, what you're standing in. So you can see that respiratory paralysis actually starts at 20 milliamps, and then your heart starts into ventricular fibrillation at 50 milliamps, and you're likely to have cardiac arrest at 200 milliamps. So we're not talking 15 amps, or we're not talking high voltages, we're talking amperage will kill you. So I've got some pretty scary pictures here about some top events that have happened, not necessarily in our industry, not necessarily at Shell sites, but we certainly have had our share of them. What are the potential sources of ignition? So you see here we've got our saw cutter, you've got smoking, you've got some faulty wiring, and product uplift. I'm thinking about things like static fires. We all have the same hazard zones, whether you're in Europe or you're in Americas or you're in the Far East. We all know of the hazard zones, and they're all over the place, and certainly the fire triangle. So if you've got enough oxygen, you've got a source, and you've got a spark of some sort. Fire is an event, and we've seen lots of these. This one actually took out a whole concrete canopy. We've seen a couple of concrete canopies. I know in Western Ontario there's still some concrete canopies. That's knocked over a whole concrete canopy. Certainly we have some incident learnings. We always want to learn from incidents. They're terrible. They happen, and they happen to a family. They happen to a person that is part of a family. And certainly we want to learn from them, but we want to actually put them back into play so that those learnings can actually stop somebody else from getting hurt or worse, becoming a fatality. We like to talk about near misses or potential incidents. We've actually got a new category now called high potential incidents, where if one more thing had gone wrong, that would have been a fatality. So we're looking at the potential of an incident or a near miss to say, if one more thing had have happened, that all the moons aligned or whatever, one more thing, not 5 more things, one more thing, would that have caused a fatality? And we look at those every few months. We conglomerate them and make sure that those learnings are actually put back in so that you guys can put them back in your JSA. If we have a massive learning, we want to make sure that the JSAs pick that up. Just showing you a few, this is actually what happened in Pakistan. This is what the guy came up against in Pakistan. So you can see there's no proper ground. There's a wire here that's open, nothing connected. So this was probably the retailer's brother had a guy that knew another guy that was an electrician, right? An electrician. And that's what we came across. So I just want to talk about bowtie again. How many have seen this, the Swiss cheese model? Kind of, maybe, Swiss cheese model. So Swiss cheese model is very simple. It's how can a hazard actually become a harm? And all these pieces of Swiss cheese are your barriers. So let's just take an example from the vacuum truck. We would expect that one barrier would be competent person. Another barrier would be that they're competent to use the gas meter and that they bump tested that gas meter. It's no good if it's off or it's never been tested. So the Swiss cheese model basically talks about you've got all these barriers in place, or you've planned to have all these barriers in place, but every one of them has a hole in it. Everyone is not effective for some reason. You've got a not competent person, they haven't checked their vent, that it might be blocked, they haven't put the gas meter in the right place or bump tested it. So you assume as a project manager that you've put that all in place and you've told the vac truck operator, and I don't want to pick on vac truck operators, guys. I'm just using that one as an example. But the Swiss cheese model basically says that all these barriers that we think are in place have some sort of hole, and when they all align, that's when we have our incidents. So the bow tie concept, again, we've got in the middle of the bow tie, you've got what we call the top event, and that's that undesirable event that could happen. You've got a fire, an explosion, somebody falls. And on the left side, you want to put all the controls and barriers in place for whatever means that hazard is going to cause a fire or electrocution, we want to put the proper barriers in place. So the pathways are how that hazard actually becomes a fire or becomes an electrocution. So if we think about the Pakistan incident, that would be an improper electrical installation to the bottom of the dispenser. That pathway takes that electrical hazard and actually becomes an electrocution possibility, right? So you have the hazards, which are, the agent, basically, that could cause harm to people, assets, the environment, our reputation. You have something that can cause the hazard, that's your threat, and then you have consequences on the right-hand side. Consequences are basically what happens if somebody is electrocuted or we have a fire. So you can think about things like damage to assets. You can think about the person becoming hurt. You can think about their family suffering. So using that bow tie concept, if I think about these things, flammable hydrocarbons, moving vehicles, moving heavy equipment, having some raised objects or rotating machinery, or having some people at height, what would we consider calling these things in the bow tie analysis? What would they be? They would be hazards, right? How about these? Injuries, legal action, our share price falls, you have an explosion, you have pollution, you have death or fire. Consequences, right? So electrocution can actually come from either direct contact or indirect contact. So there could be overloaded circuits or fire that's caused inside the circuit breaker. And if there's a ground fault or an overload, then an indirect contact, somebody touching that piece of equipment, maybe it's a refrigerator that you're working on or the HVAC unit that has a short in it, just touching that equipment is an indirect contact. There's a lot of safety precautions that we have in place for both direct and indirect. Most of us will know what a GFI is, a ground fault interceptor. We would have them in your bathrooms, for example, where if you want to plug in a hairdryer, it has that test button, and it has a ground fault, so that if there is a fault in there, it'll automatically knock that out and knock your breaker off. That's what we call a ground fault. It's called an RCD in other parts of the world, very similar, where it's something that's protecting that circuit from actually going into default or a fault. We've got also earthing systems. Earthing systems meaning that the entire station is earthed from the feed from the municipality or the utility right through to the station. You've got safety protection that you guys have all seen. The barriers, basically, if anybody's working on the electrical panels, there's actually a cover on top of that from the bus bars where the most danger is, but you're actually in an enclosure as well, so you've got physical barriers. And when isolation is required, you want to use that tester. You want to prove the tester first, then you want to check the circuit, then you need to actually prove the tester again, retest the tester. Funny story, you can go on YouTube, and this is the do-it-yourselfers, and for less than $25, you can have 3 different testers from Home Depot. But do we actually know how to use the testers? I've got a tester with 2 prongs at home, and I have no clue how to use it. YouTube did not tell me with any confidence how to use that properly and what actually to touch and not touch. So again, call the electricians. A switch is not an isolator. Some of us do-it-yourselfers will just flip the switch off, but that's just not enough. So you need to isolate, test out, lock out, and test out. Static buildup is something different, but it also proposes a significant risk. There's static when anything goes through the pipe. So our job as engineers is keeping it in the pipe. Your job to help us keep it in the pipe through regular maintenance. But there is static buildup that goes through any flow of fuel in a pipe. So you've got electrical standards in design, you've got system designs, you've got the switch gear, you've got the site layout and the hazard zones. You want to be doing different things in hazard zones. And by the way, some of the new fuels and new energies have different hazard zones. So if I'm working beside a hydrogen for vehicles, the hazard zone is that much bigger and it's a different shape. LNG, the hazard zone is completely different than gasoline. Why? Because hydrogen burns at a different rate and it burns faster than fuel. LNG, once it's out, it will actually fog up and it becomes a hazard on its own. So it's no longer just the hazard zones that we're used to within a retail service station if you've got those different fuels and technologies at your stations. And for you guys, if you're not going to be the people that are actually installing those or maintaining them, you still need to understand what the hazard zones are that you're going to be playing in and around. You've got installation standards, labeling and drawing and keeping records, contractor training and accreditation. We really talk about the contractor competence, and we want to make sure that that's a barrier that we always want to be continuously improving and checking. End-to-end assurance is really about having those processes and procedures in place from the start through to the finish and continuing that maintenance on as we're continuing to operate the stations. On the right side of the bow tie, we talk about recovery measures. So recovery measures mean if that thing happens, if somebody is electrocuted, or if we have a fire, what do we do next to mitigate that from becoming worse? So things like you've got fire alarms and fire detectors. Fire extinguishers are always there. We always encourage our contractors to bring them because the retailers have their own, and therefore the retailers and the customers. You always have the emergency stops and emergency shutoffs, and we have the GFIs, of course, and resetting, first aid, and we go back to emergency response again. We need to understand, and we need to test, and we continuously have to play at a retail service station. They play act through all kinds of different emergency procedures. So if there's a robbery, an armed robbery, they know exactly what to do. If somebody has a heart attack on the forecourt, they know what to do. We need to work with them to make sure that if we're working on electrical, we also need to know what to do, where to take that person, who to call. We have some supporting documents and whatnot, and we've got some tools at the ready for our contractors. Working with electricity and toolbox talks. I like these 10 questions, which is really, as you're planning something, ask those 10 questions. So just to recap, electricity kills and it causes fires when it's not respected and controlled. The standards certainly apply to both permanent and temporary installations. And I'm hoping on new installations you guys see what's coming and what we need to work against. We need to follow the practices and standards. And to what Scott was saying, safety and electricity has no respect for logos, has no respect for who we're working for, which competitor we're working for, or the engineer's reputation. For new sites or extensions, large project or single circuit, you still have to follow the same basic electricity principles. Protection required both indirect and direct contact. We need to have those barriers in place, and we need to check them and test them often and periodically. And we need to make sure we use that correct isolation procedures. And it's not just for electrical, it's also for any kind of energy that might be coming at you. Think about hydraulic energy, think about pressure in a line and whatnot. So, any questions? The electricians in the room are quiet. Have I given you a kind of a, have I scared you a little bit? I was supposed to scare you. Is everybody good? Is everybody, can everybody check this poll again now? So let's just go through that. Fire is one of the risks with electrical systems. True or false? True. Electrocution from indirect contact is not a risk we see at the retail outlet. That's false. Primary barrier from electrocution from direct contact is insulation from live parts, so the enclosures or the barriers. True. The use of, let's call it a GFI, is appropriate for protection against indirect current or indirect contact. True. False. Electricians? True. A 300 milliamp electric circuit breaker installed will give protection against, don't know, maybe the electricians know. That's probably from indirect contact. And then certainly trained and accredited staff and people are the most effective barrier we have, yes or no? True or false? True. So where are we now with respect to our own personal respect for electrical safety? Still a little unclear, you have a good understanding of the basic risks, confident you have enough knowledge to do your job effectively, or you're now competent in electrical safety. Have we moved up a notch, or have we moved up an awareness level? Then I've done my job. Thank you. Thank you.